Okay, welcome guys to the next physics lesson, and today we are going to be talking about acceleration. And what is acceleration? Okay, so we started off our kinematics unit with displacement. Okay, and then we went on to talk about velocity, right? And keep in mind that these two are both vectors. So displacement was the change in, that's an E, change in position, whereas velocity, which I'm going to use in a different color actually. So let me just use it. Velocity. Velocity is a change in displacement over time. So how did his displacement change over time? How fast was he traveling in that in how fast did he traverse that distance in a certain time period? So that was velocity. Now basically what acceleration is, which I'm gonna write in, let's say, how about orange? Orange would be nice. Okay, let me try this color. Okay, so acceleration is defined as the change in velocity. So we can see some sort of like a chain reaction kind of thing here. So position, the change in position is displacement, and the change in displacement over time is velocity, and the change in velocity over time, I forgot to add that in. The change in velocity over time is represented as acceleration, and you can see how all these flows together. You go from position to displacement, from displacement to velocity, and from velocity to acceleration. And I did my kinematics unit, my lessons in this order to show you the flow of how these things connect. So acceleration is basically how velocity changes. So I mean, in everyday life, you can hear you hear people use the word accelerate, like accelerate. No, so when someone says accelerate, what does it mean? It usually means that the person his speed is increasing. How about the word decelerate? When we say this decelerate, we normally talk about the person's speed that is decreasing. However, in physics, we don't really like the word decelerate because it causes it causes a lot of confusion, and I'll show you guys what I mean in a few seconds. But we just don't use the word accelerate. We use the word negative acceleration if we want to use if we want to talk about an object going in the opposite accelerating in the opposite direction. And I'll talk more about that in a few seconds if it's confusing right now. So let's first of all define the formula for acceleration. So acceleration is denoted by a lowercase a with a vector hat because acceleration is a vector. And what do we say over here? What is acceleration? It is a change in velocity over time. So we change in, remember, change in is always denoted by the delta, the Greek symbol delta. And velocity, wow, what was it? It's a v, right? With the vector hat. Over change in time. So change in time. And this is the formula for acceleration. Acceleration equals change in velocity over change in time. So let me give you an example right here. For example, let's see, a car travels at 5 kilometers, no, I'm not using 5 kilometers, 5 meters per second north and accelerates to a speed of let's say 7.0 meters per second north. So what is acceleration? So what is acceleration again? Acceleration from the previous definition equals change in v over change in time. And what is delta again. Delta something usually means that something, the final of that something minus the initial of that something. So in this case, that something is a velocity, so the final velocity minus the initial velocity over change in time. Oh, and I forgot to put time in, let's say, 5 seconds, okay? So what is this final velocity again? Well, it says right here, this is the final velocity. So 7.0 minus 5.0. And I probably shouldn't have written speed right here. I should probably use velocity, but you guys know what I mean. So 7 minus 5, because 5 is positive, because we're both traveling in the same direction and we're taking that north is positive. So since north is positive, both 7 and 5 should be positive. So it's positive 7 minus positive 5 over change in time, which is just 5.0 seconds, equals 7 minus 5 is 2.0 over 5.0, right? And then this gives us 0.4 meters per second, if my math serves me right, if my mental math serves me right. And direction, north, because remember, acceleration is a vector, so we need both the magnitude and the direction, right? Okay. So that is basically this is how we solve an acceleration equation. Now, just one quick note, and this is really important, and I need you guys to listen to this. So I didn't touch about this early on in the previous velocity video, which I forgot to, and that's my bad. But here I'll talk about it right now. So I'm going to ask you this question: Can an object's velocity, is it possible to move for an object to move with constant velocity? Constant speed, sorry, but not constant velocity. And let me write that down if that wasn't clear. So is I'm actually gonna write down in the what is a standing out color that I can use to emphasize the importance of this? White, I guess. Is it possible to move with a constant, hopefully you can read my handwriting, constant speed, but not a constant velocity? And I should have talked about this in the previous video, but I didn't, so that's my fault, because this is a really important concept actually. So is it possible to move with a constant speed but not a constant velocity? Is it possible? Think about this for a second and pause the video if you want to. And yeah, so pause it right now if you want to think about it. Okay, so hopefully you guys thought about it. I know that's a quick switch, but hopefully you guys pause the video if you want to think about it. But if not, then I'll just continue. So the answer to this question is yes. Now think about this for a second. So let's say, for example, your car travels at, let's say, 50 kilometers per hour, but at a constant speed of 50 kilometers per hour. So let's say you're driving the car. I'm going to draw a car here. Draw a car, and he's traveling at 50 kilometers per hour, and I'm going to say like east. Okay, so this car, you're in this car, and he's traveling at a constant speed. So at a constant speed of 50 kilometers per hour. So he's traveling at a constant speed, but doesn't necessarily mean that he is traveling at a constant velocity. So what if the car turns? So let's say this is the car. I'm going to represent it by the box, and he's turning, he's at a traffic light. So I'm going to draw like a traffic light here. So he's at a traffic light, and he's turning from east to, I'm guessing this would be north, right? Because east, west, south, yeah. So he's traveling here. He's going now north. But when he was turning, he was also traveling at the same constant speed of 50 kilometers per hour. So he's traveling at a constant speed, but is he traveling at a constant velocity? And remember what velocity means. Velocity, since it is a vector, it has both magnitude and a direction. Now, although magnitude stays the same because the magnitude is still 50 kilometers per hour, but its direction changes, right? Its direction changes. So since its direction changes, its velocity is not the same, even though it is still 50 kilometers per hour. So the answer is yes, it is possible to move with a constant speed, which is the magnitude, a constant speed, but not a constant velocity because the direction changes. Same thing goes with acceleration. In this case, since he's turning, he is accelerating because even though I guess you can say it's 0 meters, zero acceleration because his speed is constant, but since his direction changes, he is accelerating. Okay, so that's basically all of this. So now I'm going to talk about what acceleration. Talk more about what I talked about in the first part of the video. What acceleration, like all the confusion between deceleration and all that. So, if an acceleration is positive, what does this mean? It doesn't always mean that the object is speeding up. Let me give you an example. Let's say an object speed. Let's say I'm going to define north as positive again and east as positive. Okay, so what if an object is traveling? If Bob is traveling, Bob's speed, okay, let's say Bob's velocity is 5.0 meters per second south. Okay, but his acceleration is 2.0 meters per second north. We can write this as, since north is positive, we can write this as 2.0 meters per second. I'm going to ditch the direction for now because since we already define a direction as positive, we don't really need the direction right now. So, and since this is south, it's the opposite of north, so it's negative 5.0 meters per second. Okay, so let's think about this for a second. His acceleration is positive, but his initial speed is negative. So does that mean that he's speeding up, or is he not? In fact, his speed is actually decreasing. Let's say, so for example, after 1 second, his speed would actually be negative 3.0 meters per second. Why? Well, let's see. Acceleration is what again? Change in v over change in time, right? And what is actually v2? So the second velocity, the final velocity, minus v1, the initial velocity, over change in time. So we said here that acceleration is 2.0 equals what's v2? That's what we're trying to find, right? Minus v1. v1 is what? Negative. Because it's south, so it's negative 5.0 over change in time. And what did I say the time was? I said after 1 second, so it's 1. So we can solve this equation. Becomes negative times negative becomes a positive, right? And you can bring it over. We subtract both sides by negative 5.0. So this would become 3.0 equals v2, and that was how we got this answer right here. So we can see that his speed is actually speeding down because he was actually traveling. His initial speed was 5.0 meters per second south. Oh, just froze a bit there. Whereas his final speed was what? 3.0 meters per second south. So we can see that although his acceleration was positive, what was it again? I forgot. Was a positive 2.0 meters per second north. Even though it was positive, his speed actually decreased. So we can sum it up with a few. I'm just gonna sum it up and just writing out, I guess. So if an object's speed, if v1 is positive and acceleration is positive, then the object's speed will increase, right? Will increase. However, if v1 is negative and acceleration is positive, like what we saw just now, his speed will actually decrease in the sense that the magnitude say right here, I should define it as magnitude, because if it's actually decreasing, then you're actually going more negative. I guess you could interpret it both ways, but just to make it clear, it's the magnitude that's decreasing from 5 to 3. And if, let's say, v1 was positive, but acceleration is negative, what will happen? What will happen to the magnitude of velocity? What will happen? Think about this for a second. If he's traveling like north, but his acceleration was south, would the magnitude of his speed increase or decrease? It would actually decrease, right? Because it's the exact same as this one. Because acceleration is in the opposite direction as the velocity. And if velocity was negative and acceleration was negative, what would happen? It would actually increase, but just more negative. So if his acceleration was negative, his final speed would be even more negative, right? So we can make a rule. And I'm gonna write this in like blue or red. A rule. If the signs of velocity, let's write v, of velocity and acceleration are the same, then the magnitude, remember del bars means the magnitude of the vector, the magnitude of velocity will increase, as we saw up here. If it's positive and positive, it will increase. If it's negative and negative, it will increase because both signs are the same. And same thing, if the signs are different, oh my, what was that? If they were different, the magnitude of the velocity would decrease, right? As seen here, because the signs are different, negative and positive, so it decrease. Same thing here, positive and negative, different signs means decrease, and that's basically all it is. So keep in mind that the word decelerate, what does it mean? I mean, in terms of physics, we can look at this. Look at this chart I made up here. What does decelerate mean? I mean, if you're traveling in the positive direction and you decelerate, does it mean that your magnitude decreases? The magnitude of velocity decrease? I mean, the word decelerate is just ambiguous, you know what I mean? So it might make sense sometimes, but you know, physicists generally don't like to use this word, so I would just scratch it out. Just use the word negative acceleration or positive acceleration. It will make much more sense. So that's basically it. This is acceleration in a nutshell. And so yeah, and once again, the formula for acceleration is the change in velocity over the change in time. So hope you guys enjoyed this video, and I'll see you guys in the next episode. Peace out.